Hey, hello. It's Python 0 to Hero again. And yes, I have to think about what I'm doing. Oh my god, I'm not awake like every week, it's Sunday and yeah, so this is usually the first thing that I do. Like, of course, I wake up and do a little bit of things at home, but usually the first thing that I do on Sunday is Python 0 to Hero, which is great. I mean, it's a good thing to start the week if you think Sunday is the first day of the week. Um, so yeah, it's great. The weather is getting better. It was raining this morning. The floor is a bit wet because I got a little balcony, so I can tell whether it was raining last night. So yeah, so everything's good. And today we're gonna talk about generators. And so yeah, I don't know whether you know that. You can grab the slides there on top with that, link there. All my slides is on slide deck. This week will be super busy because EuroPython is starting. I will talk a little bit more about EuroPython. At the end, I think it's not very important at the moment. I just want to, yeah, let you know what's going on. And so let me go back to my slides. Otherwise, I can't switch. Okay. So yeah, we have so many things. So I know that it started as like a tutorial for absolute beginners. We have done that. We have actually covered quite a lot of beginners topics. So we also cover something more practical like testing and yeah, and now we are actually like going into a more intermediate topic in my opinion. Spelling error there. Sorry about that. Yeah. Uh, yeah, sometimes like I prepare the slides very late and then like my Grammarly is off for slides.com because the JavaScript doesn't work together very well. So yeah, sometimes create something weird on my slides, so I turn it off. But like that which means that there's a lot of spelling errors in my slides. Sorry about that. You have to tolerate that. I have to really like go back to proofread it, but I was too tired. Um, so first of all, what is a generator? So last time, remember we covered the iterator. So um, iterator is super useful because in a for loop, you need an iterator to actually give you the result one by one. So every time you go through the loop, the iterator will do something and give you back, you know, a result one by one. And at the end, there will be like a stop iteration, error. Is it called error? Like it's an error, but it's stop iteration. Basically, it's just like control the for loop to stop. So it's super useful. And remember last week we have built an iterator, very simple one, but we have to write a class. So because it's an object, we have to create it like all other objects. We have to write a class, so it kind of like is a constructor of an iterator. And then we write we need to have a next, and then we have to have an iter. So, which is quite complicated. You don't want to do it all the time because it's sometimes you just need something to look through very quickly, and then you don't want to implement a class every time for something that you may use only once or twice. So that's generator come in. So generator actually I'll show the code in a bit. Like it will really look like if how you write the function. So sometimes it's called a generator function. So a generator function so lets you declare a function and then like behave like an iterator. So it's a it you can think of it as a shortcut to make to create an iterator without writing all this class iter and all this stuff, and it could be used in a for loop. So this is the syntax. I copied. I forgot to put a link there, but yeah, I copied from one of the tutorials. So actually, we can put it in our Jupyter notebook. So I have used the theme, Jupyter theme, if you want it. I think it's pip install Jupyter themes, or you can find it on PyPI or the GitHub. So yeah, so this is very nice. Then I can use that one in my Jupyter notebook, which I really like because I really, really don't like the background being white, so my face is super bright because of my screen. So yeah, so you can see that. Have I yeah, it's fine. I think. So yeah. Well, this is very similar. I hope it's big enough for you. So this is super similar to a function call. The only thing difference is that in the function you have a return, but here you have a yield. Actually, you can have a return as well. Nothing stopping you to have a return in an iterator in Python 3. I think in Python 2 that's another story, but in Python 3 you can write a return in or return, I don't know, return n. Yeah, you can write an iterator, write a return in a generator. But let's not do this for now. So if I run it, it's fine. It's a perfect syntax. It got a U there, so that makes it a generator. So that makes it different. And you can see that now we have this first and here. So let's see if we can loop fluid for item in first and. So you have to put in an n. So it's kind of like a range. So let's put in 10 here. So print item. So let's see what's going on there. Oop, wrong. Yep. So right. So you see that it's just like a range, right? So 1, 2, 3, 4, 5, 6, 7. So actually each time, it will this yield will give back a number which is increment every time, but it will stop when it kind of fail this while, then it will stop. Maybe I can like print is done. So when it's done, they will print out it's done, and then num equals to, I can print out num here. Yeah. So you can see that when it's done, num would be equals to, actually it will increment by 1 the last time. Oh yeah, actually I'm not so sure. Let's have a look. So let's do this. Oops. And I was saying print is not indentating correctly. So uh, or maybe I mixed the tab and the spaces again. So I can't tell in a Jupyter notebook. That's a bit annoying. So I would just like use for spaces. No. No, it's a tab. I can see it there. The theme is quite very difficult to see. So I don't know why it doesn't like it. So maybe I'll put it in a while loops to see. Or the tab is actually different here and there. Is it? Yeah, it's just some like weird indentation stuff. I should actually change that into spaces. Well, whatever. Okay, so let's run this again. Yeah, it's done. When it's done, it's 10 because when you go through it, so last time, it would be a so n is 10, right? So last time num would be 9, and then it will yield 9 when we call it the last time, and then it will increment by 1, so it will be 10, and then it will hit this print and then print it out. And then actually this is done. So like you can actually return it here if you want. Like I said, it's Python 3, so it could return something. And then if I return, then it should return, let's say returned num. So here, and so this would actually be num. But like what I can do is like items equals to. So let's see what would happen. So no, this is item, right? So it's just like, yeah, I'll just keep print item. Oh, okay, let's see if there's any difference. No, oh, I haven't run it. Oops. Oh yeah, same indentation problem. I gotta replace it with a different tab there. Yeah, it's not printing out because I just returned it and there's nothing to receive it. So you can actually, yeah, it's not doing anything here at the moment because I put it in a for loop. But if it's in other, context that you use it in a different way, I will show you later. There's a lot of ways to use the generator. This is only one that you put it in a for loop, using it like a list, or using it like a just like a iterator that we have created last time. Then return is not doing anything at the moment, but you see there's other way of using the iterator. Yeah. So this is a very simple thing, and then now we can inspect what's inside a generator. Like I'm super curious because this first and here should create an object, right? So if I print it out, what would give me? N is not defined. Yeah, I know. So let's put 10 there. It created a generator object. Okay. So it's a generator object itself. So let's assign it to gen object. Okay. So let's have a look at what this gen object has. So gen object. And yeah, you can see that it got the iter like we, expected. And it also got a next, right? So actually, like this generator object is also an iterator. Is iterable because it got iter, and it's also an iterator self because it got the next, right? So yeah, so it's different from a function because if you write a function, so let's create a function, okay? So let's create a function. So let's save my func. So yeah, I just write a nothing function. So let's have a look at my func. So what I can do is like dl my func. Okay. So you see that it's different because if I write a function that doesn't have the u there, then it won't have the iterator, the iter. It won't have the next. Okay, so it's different. Um, yeah. So you can also call the iterator of this gen object. It will be fun. So let's have a play. So if you want to have a look, what's the iter of this gen object? So also I want to compare. So let's print out the gen object again. So yeah, so basically they are the same thing. So it's what we expect from an iterator last time, that when you call iter on itself, it just returns itself. Okay. So yeah, that's the kind of internal of it. So yeah, so there's some difference that we have noticed from the generator and a normal function. So a generator function contained one or more use statement. I haven't read one that contain one more because in this one the demonstration code here is a while loop, so it kind of like just have one u. But you can actually if you don't write a loop, you can u1, u2, u3, and then you just give u1 to 3, and they will end. It will have stop iteration. Um, so yeah, so you can have one or more, but if you don't have a u, that is just a normal function. It's not a generator function. So that's the only like difference when you're writing it. Let's put it that way. Of course, internally it is so different. Um, what is called, it will give an iterator because you can call it. So like yeah, it will give an object, iterator object. So you see that when I do the first n and then put in 10 in there, it's just like range, right? It create a iterator, and then but it doesn't start execution immediately because you can see that if let's say I put something here. So if I put like print, we are ready. We are ready. Okay. So I put it in here. Oops. Oh yeah. Stupid indentation again, is it? What are you doing? Yep. So now if we do something like I just create or my uh, object. So if I just create it, yeah, it doesn't do anything yet. It doesn't print out we are ready yet because it's not execute directly when it got created, because now we just create my object and there's nothing. So here we can actually do like my object. It's the same, and then now, yeah, and then now it will be like we are ready because when it go for the first iteration, then you see that we are ready. Or if we let's make it smaller, so let's make it 3, okay. Then here I can say like print, you know, yeah, I just want to print this out. So every time it go for iteration, you just print out this separation, so you know where it goes to where. So yeah, I see that like we are ready, and then it just like because when you run this for, and then it will start executing, and then it will yield a 0 here. Okay, so it got print out here, and yeah, so you can see that this item is created when we execute this. And then when we print it out, then you just print it out here. So yeah. So basically, it is created when we hit this line. So it's not created here. It's created when we hit this line, and then we are ready. And then item is already 0 at this point, so we can actually iter. Let's say item, so it will be already in there. Just print out the item. So this is, yeah. Oop. What have I done? Oops. Yeah, okay. I don't know what's going on there. Oh yeah, because like my object is expired. So yeah. So you can see that the item is created here, and it go through this. So iter 0, iter 1, iter 2, print out the item, and at the end when it finished, then it was just like, oh, okay, I will just print this out, and it ended, and then yeah. So that's what's going on. I hope this is showing, like, yeah, it's difficult to show what's going on inside, but I hope that clear a little bit. Um, so yeah, ask questions if it's not clear. I was try to show it like in a different way to make it like more obvious. But yeah, please ask questions. I'm having my computer which occasionally crash and my phone on my desk, so I hope that I can see all the chats now. I really hate when I miss people's chat. Like I feel so sorry. I ask people to type something and then I just ignore them. No, I don't want to ignore them. It's just like my computer sometimes crashes. Um, so yeah, and also it has a next method. So actually, instead of putting it in a for loop, you can. So you can create another my object. So you can have another. So this is already we are already playing with it. So let's be more organized. So let's put it in here. Okay. So let's create another. So another object equals to first and um 10 again. So we could actually call next on this one. I could just put 3 there because like I don't want to print out too many things. Okay, so we can actually just call next here, like like we did with the iterator. So this one will return. So this one because yeah, it will return. So this one is from the print, right? But this one is what it got returned. So I can be like item equals to. So it doesn't print out anything, but because it's lazy, right? So it's not executed when this is not useful. So now it's like we are doing nothing with it. So it's just sitting there. It's not doing anything. So then we can print out item. And then we can print out 1. So the print statement inside the iterator it just got yeah, it just got ignored. So let's create another one. Yeah. So here you can see that it's different because so what is happening is that we created it. It's not executed yet. Remember, we created and not executing it. So when we call next, it got executed. And but the item we don't print it out like before, because before in the for loop we just print it out, right? So this time, we would yield with yield and then the num here. So it got yield and it got returned. So it's kind of like returning the function. So it got returned. So instead of return, it just so return will just end the function, right? Remember a function, if you change it into a return, it become a function, and then it will just return the number. It you know, and next time you have to run, call it again, which create another function object, and then it will return the same thing. But this time, because it's an generator, so it's behave like an iterator. So when you yield, so when you call next, so it will yield that number for you. So it will yield that number 0. And oh, actually the 0 is lost here, right? So because the 0 is lost in this item, and then when we print it, yeah. Oops, sorry, let's do this again. Yeah. So like it will return the 0 here in the item, and then the item we got printed out. Okay. So yeah. So this yield is give you back. It's like it's returning this num which is 0. But it just hold on there. It just pause there. And if you call it next time, so this time, we got 0. That's great. And if I do this again, so if I do this again, so item, let's call it item 2. So if we do this again, then what we'll get, so we don't know what is item 2, but it become 1 because the iterator, it is basically got frozen here when I got, first time, you created it, I do nothing. Okay, when you first call next, when you call it, okay, like yeah, I do this, we are ready. So here num is 0, so I give you 0, I give you back 0, and I got pause here. So this thing, my object, so this object that we created, it got frozen. So it just stayed there, and then until you call next again, then it pick up from here again, and so okay, num plus 1, and then I'm in the while loop, so okay, I'm still less than 3, okay, fine, and then this time I give you back 1, and I pause again. So this is what actually this is doing. So that's why this is a bit ambiguous in the for loop, because a for loop do a lot of things under the hood. So it got executed, and then like it assigned. So basically it's like what I do like in another item. So I assign item equals to 0, and then you can print it out as much as you want. And then when this 2-step is finished, you go back to this for loop, and I will call next on my object, and I will have the next item, which is 1, and I will do this until it's done. Then I call this again. So for example, next time, so it's the last time, so num is 2 now, and then I call next again, and okay, num is equal to 3, and then oops, okay, I don't do this for while loop, and then I print it out, it's done, num is 3, and then you can return, but there's nothing to return here, so return none, so it's done, return none, so nothing is done. So it will also raise a stop iter at the end, so when it reaches the end, it will raise a stop iter to tell the for loop to stop, and it just, it's done, it's stop. That's what it's doing. And yeah, so basically this is, breaking down the for loop for you. What else are we talking about here? And yeah, so this is what I just said, like when the yield is core, it's just like frozen there, just paused, and I just sit there, that object is stay, so it's like saving a game, you just stay in the same state waiting for you to call it again. So yeah, so it's remembered, so you won't lost that, the num is equal to 0, num is equal to 1, it will still be like that, it's saved. And when it terminates, there's a stop iteration raised, because we know that the for loop will only stop when there's a stop iteration. So when it hit the end, so when it hit the end of the code, there's no more code, it will just raise a stop iteration. Or when there's a return, I think it's the same if there's a return. So let's experiment. So let's put return none here. So I just force it to stop, and then I can okay, I have to patch all this indentation, otherwise I'll get another error. So print after return. So you see that this time it won't print out after return, because return none. So I force it to raise the stop iter here to stop it. So it just, it's just stopped. It won't print anything out. So this is like your function, right? When you have your function, when you return something, it just, terminate. It will be gone, and there's nothing else. Like the code after the return won't be executed. So, sometimes when you write a function, if some condition is satisfied and you just want the function to terminate, you write a return in there. So it's the same case with the iterator. When it hit the return, it's just like, okay, I'm done. Um, but yield doesn't do the same. Yield will just save what it is having in the iter object itself. Okay, in this generator itself, it got saved there. Um, so I hope it's clear. Do you have any questions at this stage? If you have it, it's a good time to ask question before I go further down into explaining things. Um, yeah, so it's got a little bit complicated now, because this generator is actually very powerful, and you can see how it will lead to async eventually, which we will talk about next week. But you'll see now one step closer to how we get async from in Python. Okay, so the key lies in this sending to generator thing. So let's go back to see our generator. So you can actually call a function send to the generator. So you can see that in the generator here, we have a send method. So this send method is actually quite important in some cases. So what it does is that this send method will resume the generator and send a value that could, you know, so it's let you talk to the iterator. So now it's just that whenever there's a yield, the iterator will give you back something, right? If you give you back like, the num, or it could give you back something, so it's like returning something. But if you call send on an iterator, I mean like you call the send method of the iterator, of the generator, then the generator will receive a value from the send at the yield. Well, this is a bit confusing. The first time I knew about it, it's like what? Um, yeah, and then like and then and then also at the same time it would, so it's kind of like if you yield another value. So if I yield let's say happy, and then if I send sad, then the generator will receive the sad and then will yield a happy for you. So the generator send a happy to you and then it will receive the sad. um yeah, it's very strange. Let's try to have a look and see if we can do better. So I have a code snippet here to demonstrate this. So let's copy it and put it in our Jupyter notebook. Again, like the code is from here. I try to put all the reference that I could in the code. Sometime I forgot, so don't be mad at me. But yeah, I try to. Okay, let me fix all this indentation because I copy and paste a lot, so this is a bit messed up. So let me yeah, fix this, save some trouble. Okay, I should probably fix this as well because when people play around, like I will upload this Jupyter notebook in my repo. So the repo will be in the description. So it's just from my GitHub account. You'll see there's a Python. I think it's called 0 to hero. Yeah, just the number 0 and 2. So 0 to hero. So that's the repo. So my GitHub account name is Chuckting, Cheukting. So I hope you can find it. And yeah, I will upload all this on the GitHub repo so people can play around themselves if they want to. So, so yeah, this is the code snippet. So we have a number generator, very good name there, and we take in a value, and then so this is a bit different. So before we just used yield like return, right? But now I can assign yield to something, and yeah, what's going on here? Uh, and then this will be called a number, and I will just check whether the number is smaller than and. Then, so this is super funny. So what is like why? So what this does, as like what I said before, what it does is that it will take this number that I have get last time. So at this point, you should received a number that is given by the send, and it will be assigned to a number. And then if this number is smaller than the maximum that we set here at the beginning when we create this generator, then next time we call it, this value will send back, and we will take in something new in here, and then we'll add 1 to the number. So yeah, so let's run this to see what's going on. Okay, so the maximum of this generator is 10, so anything bigger than 10 will just terminate the whole thing. It will stop iter, and it will, it's called G. Okay, so when I call next G, so it got executed. So now, well, I would be like, I need a number, and then what I do here is that I send this number in, and then it just got returned. So it's so what I would like to do is I want to write something here. So maybe I would say inside gen, and then yeah, I just gotta, oops, yeah. So yeah, I want to inspect it a little bit further, so I would do this, and yeah, so you can see that inside is 5. So what happened here is that when I first call this next here, so it will start executing, and then when I send a 5 into it, then this would become 5, and then it will print this out, and then it will give back 5 when I, you know, yeah, when I, because like this is also calling G. So what are you? And it's giving back 5 here. So now it should be 6 inside. So I can't really look inside from here, but I can call it again. So yeah, it's kind of mixing up a lot of different concept here, but that's why it's very yeah. So this is 2. So this time when I call it, it will get a 2 here, and yeah, it will. So this is different because I think yeah, because this is the initialization. So here, when I do this, actually 2 will be given to number, and a number will be increasing by 1, and then next time when I hit it, because I have to print it, so what is number, and then this one will give me 3. Okay, so this is different from the first time we called it, because yeah, because this is we initialize it here, so it's a bit different. But this time, because we are calling it a second time, so it will hit this number plus 1 before we returned it. So yeah, before we yield it again, so we have a 3 instead of a 5. Okay, so if you want it to be like every time if you get something and increase by 1, then you have to you have to put it here. But let's keep it like this, and how can I make it more clear? So yeah, so this is yeah, maybe I can be here that getting print number number. So you can see that this time if I call it again, and then I call it 5 again. Okay, oh, not 56. It will stop. So if I do this, okay, so yeah, this is the same. This is so we get number 2, and it will plus 1, and then next time we come back, it will be 3, because I need to print it out, and I'll ask like, oh, what is the number? Please give me the number. So this will be 3 because I'm using it, and it will got frozen here until I call send again. I call send again, and yeah, it got 5, and it becomes 6 because it just stopped here, and then yeah. So the only strange thing is like when you started it, because you have to have the number to enter the while loop. Otherwise, it will say like, oh, there's no number. So so yeah, that's why we need to start it like this, and then when we get the 5, the first time we get the 5 here. Okay. So basically what this does is that, okay, so let's walk through this. So when we call a number generator, so it's created the object. Remember we created, we never execute it when we create it. Okay, so it become a G. So when I call next G, so it will start executing, and it hit this U here, and it got paused. So that's yielding nothing because, well, basically we just started. There's nothing to yield from, so we just stop here. We pause here. Okay. So we pause in this the first U, and then when we call this send 5, so the send 5 will actually give you a 5 in this. So now number is 5. So inside gen, you can see that inside gen is 5. And if 5 is smaller than 10, that's okay. And then we'll be like yielding the number 5. So we have the number 5 here printed out. Okay, so let's print out that U. That's actually from here. So now inside the generator is pause here. Okay, so and then now the second time when I do this send 2, so this actually will give you a 2 for number, and then we say getting number 2, that's correct, and it will be increased by 1, and I come back here. Okay, 1 is 3, now 2 plus 1 is 3. 3 is smaller than n, that's okay, and then it will pause here. So you can actually like do it more clear by is like going to I can't spell to you. Um, right, so this is inside, so you can see what's going on. So actually, when you like, so here, so going to you will be 3, and I will use 3 and print out 3 here, and it will go past here again until I send 5 again, and number is 5, and then getting number 5, and then going to yield will be give you 6, okay, because increment by 1 here. So you can see that. Yeah, okay, so this is more clear now with all this printing. So the only thing that's not incrementing is the first time we called it, because we are getting the number here, so inside gen, so we get the number from inside gen, and then we didn't increment it, we just yield it straight away, so that's why it's not incremented, but otherwise it's incremented. Okay, so yeah, it's a bit difficult to explain this concept. So this is how you can send it back to the generator. So now I go to the theoretical part. So this way, actually, the generator create a coroutine. So what is coroutine? So I will explain a little bit more next week, but I can give you a little, you know, a spoiler of what we're gonna talk about next time. So when you create a function, right? So a function is, like my func. Let's say I have a my func, and then this will be n, and then I'll just return n. Okay, return n. Okay, so let me replace my func with this, because that my func is a little bit stupid. And yeah, so let's replace this my func here. So when you have this my func, that's basically just return something that's doing nothing basically. Um, so this is called a subroutine, because, or you can have like n plus 1 here. Yeah, maybe n equals to n plus 1. So So it's a subroutine, because you have some code that is put away. So itself is like a mini function that we explained before when we talk about function. It's like a mini program that is sitting here. Then you can plug into your other program. You just call it, and it will run this. Is this mini program? So this is called a subroutine. Okay, so it's like a routine is like a bunch of code. So it's like a small bunch of code that's sitting there that you can run. A coroutine is also a bunch of code, but is not sitting there waiting you to run it. It's sitting there, it's created, is sitting there. When you call next, it just got paused here. It's sitting there, but is in a state that is still active. It's just got frozen. It's just got paused. It's still there, that everything is still safe. When you call a function, you create it, you run all the code in it, and then when it hit return, it just disappeared. Okay, it's done. But a coroutine was still sitting there, waiting to be called again to get the send, or when you call the next, then it will give, it will do everything and until it hit another yield. So this is coexisting with your code. So this is called a coroutine, and actually coroutine is a very important concept in async, because async is basically all this coroutine as sitting together. It's just like you have something to orchestrate. Okay, now you do this. Okay, stop. You pause it here for a bit, and then now you do this. And okay, no, okay, now you can pause it, and then let's ask, A do this again. Okay, okay, wait. Pass this to B, and B would continue to do something, and then B could. So all these routines are actually like is like playing an orchestra. People are working together, and all these functions are working together. And in async, you have an event loop to it's kind of like the conductor to conduct all these things. So having this generator, having this uh, ability to pass things around with yield and send is actually the foundation of being able to do async. And so later, people discovered that actually we can have async in Python. Then so this it started. I think it started from 3.4, and then it's just started to have more like, well, you can still do async in Python if you write a bunch of generator and stuff, but there's a standard way of doing async in Python. So that's really cool. And yeah, I won't go too deep because that's supposed to say for next week. So yeah. So is there any questions or any like, if you want to add some of your view in there, so maybe you don't agree with what I'm saying, you can point it out in the chat, and I'll see how can I explain that. You know. So the last thing I got to talk about today is year from. So it's from Python 3.3. I think someone said it's 3.3.2 to be very specific, but well, I guess I hope you're not using less than Python 3.6, so I think that's okay. You just need to know that. Okay, from 3.3 it's coming from. So it's definitely not in Python 2. It's yield from. So yield from is just a shortcut. So remember we have we have generator one, and then we can. So this is a generator within a generator. So we have two generators. So generator one within itself, it called generator two. So it's kind of nested in some way. But you can actually have a shortcut for this for loop. You can have yield from. So so yeah, yield from basically is a shortcut for this like for loop here. So what we can do is that we can see if I can do this. So yeah, I forgot to put this in a section because I totally ignore that yield from there. That's fine. Let me yeah, fix that. Usually I do this beforehand, so you don't have to sit through this. But okay, so let's try do something. So we have a gen one here. So I put in like an end, and so this would be actually this would be the mass generator. So this would be the one that calling gen two. Remember? So we have gen two here, and oops, gen two. So Gen 2, we'll be doing something very simple. So you have has an end, like, or you have. Oh, actually, we can reuse. Oh yeah, let's reuse our yeah our first end. So that's fine. So this is like a big gen. I don't know. This is a generator itself, and then it could have yield from. Yeah, there are some good example of like where it's actually useful somewhere, but I forgot to put them in the presentation. Sorry about that. I think I got a bit carried away by the send method, and I kind of forgot to come back to add it in. So you're from, let's say, first and 10. Okay. So this is so this is a generator itself. So let's have a look inside. So if we have a dir and then big gen, and then so this will create an object. So even though we don't put in anything because it doesn't take in anything, or I can actually take an n here and pass it into this. Okay, so let's make a 10. Okay, so yeah, so this is actually a generator itself because it got the yield from. Okay, so so yeah, this is a generator, but it yield from another generator. So this is a bit weird. So print inside big gen. I don't know. I just want to put a marker there. Um, so now when we call big gen, so yeah, it just created a generator. It doesn't execute, so it doesn't print out this inside big gen here. But if I put in a for loop for item in, and then I do a print item, yeah, it will be like inside the big gen, so it's run the big gen, and then it will just go into the first and. So we are ready, and then just like, because remember the yield from is like the looping through everything in this generator, right? So it's just like the for loop that we had before, and it's done and it stops everything. So this is end of big gen. So now you see that. Oh, it doesn't even print. I think the reason being. Oh yeah, no, it's printing. Okay, yeah, yeah. So it's just like carry on and end. Okay. So yeah, it's not really like seeing the power of it here, but when you are writing something like with wrapper of a lot of generators, then it's more useful to use yield from. So yeah, and the example is quite complicated as well. I found it online. I see if I can find it again and put the link there because I have all the history. So yield from. yeah, I did some research yesterday, and yeah, so people ask about like how to use how do you use from. It's just a shortcut, and yeah, there's this. I'll put this link here. So it's kind of a big. So that's why the other reason why I didn't put it in the slides, because there's a lot of like a lot of showcasing. It also explained a little bit about yield, and then you can put all these like iterator together using yield from. So it's less of a big chunk of code, but I would rather you read it yourself. See if I can edit this one. I think I have to. Yeah, I have to edit it, and yeah, I will put the link in the slides so you have it. So I don't have a lot of slides. That's great. So yeah, yep. So you can have a look at this. So this is a 2-page blog article. So remember to click next post to read to continue reading it, because otherwise you will be like, oh, it doesn't explain it because you haven't read page 2. So yeah, let's go back to my slides. Yeah. Okay. So yeah. So I think that's more or less everything about generator. I think the most important thing is to explain the send the sending to generator, this concept, because this is the foundation of async, like I said. So yeah, this is quite important. And yeah, and this, yeah, like I said, this will be available on GitHub. I'll put it on there. And the GitHub link is, I didn't put it anywhere in my slides. I don't know how. Yeah, the GitHub link is, so you just go to my repo. So maybe I'll just show you. I have time today. I don't know why, like I have so much time left, which is great. So I have, so find a repo. So this is called Zero to Hero. Yeah. So my username is Chuckting, 6UKTNG, and Python 0 to Hero. That's my GitHub repo. So you can see everything is here. Sometimes it's less, sometimes more. So last time the iterator is here, so that's the Jupyter notebook that you can see. And I'll upload today's Jupyter notebook right after I stop streaming. And yeah, and that's thing. I didn't put in the license here, that I? Oh, I put in is MIT, is it? Yeah, I make it. I mean, make it Creative Commons. Yeah, MIT. Yeah, I mean, make it Creative Commons. Everybody can use it. I don't really care if you use it in your own thing. Um, so yeah, that's it from me today. So I know there's a bunch of people who just joined. I'm sorry that like we kind of reaching the end here. I want to spend more time with you guys. Or you all. Sorry, I should not use hey guys. I want to spend more time with you all, you folks. Um, but yeah, this is the end of the tutorial. You should come in earlier next week, I would say. Um, actually, I'm thinking about taking a break next week because it's EuroPython. Yeah, because let me go to the last slide. Okay, so next week it may be actually means that it's the week after next, because next week we have the sprint at EuroPython. So I don't know. Maybe I could also run it. It's only an hour of my time sitting here and presenting, but it will be a EuroPython sprint that I will be hosting a project. So there will be people, but the sprint started on Saturday, so I am guessing, and also this is Sunday afternoon, so I'm guessing people are already kind of more or less, you know, on the roll. So they may need to just someone to ask answer the questions. So so yeah, maybe I can still do it. I really want to talk about async. So so if you want to know which program is on when I'm taking a break, follow me on Twitter. So my Twitter is also checkting_ho. So it's the same as my Twitch account. So I'm lucky to have both under my name. And it will build on the concept of of generator. So like this is the last chance if you ask any question about what I told you today. So so we go from iterator, and then we go to generator. So like and then now we know that you can actually have all these generators sitting there and talk to each other, and then we can do async. So So that's really, really cool. I think that's why I love Python. Um, so yeah, next week there will be no. So next week I'm talking about the week coming. So for me, Monday is the first day of the week. It may be different for you, but yeah. So the coming week, there's Wednesday there's no Meet with Pi because we have EuroPython. Because Lace and I are both organizers of EuroPython, so we'll be extremely busy. Um, and also we will both be speaking there. So please, if you haven't got your ticket yet, I think this is your last chance to get a ticket. It's not expensive, and also it's kind of like a support to the community. Even if you like, oh, I have no time, I really can't commit to the conference, you can come to the sprint next weekend. So like I said, I'll be running a project, so it will be a documentation with Terminus DB. So not just documentation, like you can also write tests. We welcome people to help us write tests as well. So I will also have to spend time preparing some tickets for that sprint. So that's why I'm super busy. Um, but one thing that you can learn that I can guarantee you is to learn how to write documentation in a style of NumPy. Write docstring in the style of NumPy. So this is something that I think of giving a presentation about that in the sprint as well, which also a topic that I want to talk about in Python 0 to Hero, like how to write docstring, how to use Spanx, and all these things. You will have a head start if you come to my sprint at EuroPython. It's free to join, you know. Um, and so just check out EuroPython's website. And um, yeah, and next tomorrow I will still run the tutorial of Legend of Data, because Monday I can still have some bandwidth doing that, even though I'm super busy. Um, but afterwards I will be super busy. I'm still thinking like so. No Meet Me Pie on Wednesday. I'm still thinking about Friday, World of Wacocraft, and also I'm still thinking about next Python 0 to Hero. I think I'm still tends to do that for next Sunday. So let me know. What do you think? If you have, especially if you have questions about iterator generator, please ask me either on Twitter or on Twitch or whenever, whatever you feel comfortable. Ask me questions. I love having interaction with your yeah, because it's fun. That's part of the fun. So yeah, so I think that's it for this week. It's a bit shorter than I wanted. I don't know why it flies through very quickly because I guess there isn't many questions. There's actually no questions. Um, but yeah, but I'm so glad to be like going through this journey. Really glad that I did this. I'm really enjoying it myself. I hope people are also enjoying it. People are learning Python. Um, that's what I think I want to do. I'm part of the community. I want people to enjoy it as much as I do. So yeah, so I think that's it for me. And have a nice weekend. Well, if the weather is nice, go out and enjoy. Thank you for sitting through this tutorial. And if you're watching the recording, also thank you so much. I really want to see people to come in live and ask questions and chat with me. That keep me going. And so yeah, hopefully, if not next week, the week after, we'll talk about async, and then maybe we can go back to talking more about like practical stuff, maybe more about documentation. That's one thing I want to do. Also packaging, how to release your own package of your own Python libraries, and then other things like, for example, there's plan to like create a CLI tool using the Python client. So I may also talk about like creating a CLI like application, command line interface, as CLI stand for. So a command line interface with Python as well. So that's another thing that I could talk about. Yeah, or maybe I got inspired by like some talks in EuroPython and want to talk about something. And oh, by the way, one of our honorable guests in your Python is Mr. Guido himself. So if you want to, maybe have some Q&A with him, or maybe like listen to his talk, that's your chance. So please sign up for your Python. I'll be so glad to see many people enjoying the conference. So I think that's it. I have been mumbling a lot, and yeah, I will see you very soon. So bye.